Before we start, it's worth to mention that Next Limits started releasing various flavors of Reflow as plugins for 3D applications such as Cinema 4D, Maya, and 3D Max to make it easier for artists to work out everything inside their 3D application without the need to transfer data from and to Reflow, which is good for new users and for scenarios which don't really have a lot of time to get done, but not completely for bigger projects or for experienced users who will need to use more of what Reflow is offering inside this standalone version, such as Hybrido, its destruction tools also, and some of its programming capabilities, like in Graph Editor, which is really worth it, as it's always better to separate things when working on bigger scenes for your management resources considerations. We in our daily work actually between even Maya and Maya, Max and Max, Maya and Max, Maya and Houdini, we do transfer data, and we need to have the tools to transfer data between these applications. Actually, Realflow is a pioneer in this field, and it has new extensions. Now, Reflow is covering or exporting things using Alembic files, as you will see, as well bin files, other extensions like BRT for Krakatoa. Having Reflow standalone software does actually offer full simulation environment to create, animate, and handle and modify, and to visualize everything in a more customizable way to see everything actually. One of the most annoying issues about exporting and importing objects between 3D application and Reflow was the scaling issues and the system units, which actually was mostly solved in the last versions of Reflow, as you will learn more about this during our course. I will try to do some mistakes in this course in order to see how we can work out things. It's the best way to learn the actual daily problems you may have during your scene setup, tools preparations, and even simulation. As well, I will do everything from scratch, try to establish everything with numbers. You'll see how we plan things, because I don't believe having the project files ready and going through the network, trying to explain what happened is a good way to teach something. We will do our best to do these scenes from scratch, and eventually you will have full simulation and full scene which you can use for other scenarios. Here we have the whale jumping from and into the water, and we have another major scene which is about creating stormy waves, rolling wave on the beach. You may change or replace these objects later. As example, you can put big alligators here or other creature, and you will have the same interaction. It's always good to build up something and make it work for other things. Imagine that you have this project for a commercial or for a shot in a movie, and you have everything set up. All you need is to re-import some objects, try and test how they are interacting with liquids. The main thing is that the scene scale should really match. So in case you will have alligator which is smaller than the whale, you take that in consideration by just resizing the scene or trying to have the actual or realistic scale for the alligator, rather than having a scene which is 50 meters almost by 30 meters or 20 by 40. And all you need to do is small steps then to simulate everything. Now let's go and start our first project. Our first project will be the beach rolling waves. And basically what we will do, we will try to establish a scene which will be useful for the whale project, which has a lot of waves. So what I have here is land, or let's say a coast, and the water gonna come. It has an angle, gonna come from here. This is the level of water. With the forces, it will try to push and pull back from here, forming the kind of waves which we want to deal with later. Also, I will make it a little stormy, so we will have the rolling waves. These are supposed to be some rocks, but we will replace them with better geometry later. Now it's a proof of concept. Also, if you notice, I have a box here which is empty inside, which is displaced here, just to have some interesting pattern for the waves when they roll in and back. But usually we do one geometry. If you see here, it's just not easy to pick. I will hide this. This is the geometry. I tend to export volumes. That's why I made some walls for it. Rather than to export one plane, the idea is that RealFlow likes to deal with volumes. It's easy to detect as collision object. So I will go back and I will export everything here, but I will just not export this plan, at least now. So I can go to export SD object, select the object, current frame. I don't have to export animation, and I will just export it again here, like container 2 or 3. I will just call it container 3. Export one frame. I don't need to have animation. I also can export it as Olympic files, but I don't need to do that because there is no animation. There is no need for that. We can also export it as object file. Let's jump to RealFlow. Here I have a new scene. I can create a new scene by going to new project, new, and I can just create empty scene. Already I established this scene, and now I want to bring some geometry here. I can do that by going to import, geometry import. Also, I can do the multi-body, but in this case, I don't have except just a few objects which I will need to deal with separately. If I will import them as multi-body, I will apply all the parameters to all of them. They will have all the same parameters. It's useful again for fractured objects. But import here, I can also go here and say add object import. Here I can go to the project files. I put this container, or the same one I renamed there, container 3 as the same object, and I can import it here. Now before we start doing anything, again, the units here are the axis setup is Lightwave and Cinema 4D. I will leave it like this. The best thing to do is to go to 3D Max or Maya here, because I'm dealing with 3D Max, but I will leave it like this, so we'll deal with the problems later. Now, the second thing to say or to discover is the scale, the scene scale. For this scene, I would say that we need a large scale scene. So if we will look at it, let's say maybe we'll need some 20 meters with 30 meters just to have really interesting waves. So to make sure that we have the right scale, we can go back again to 3D Max. Let's display the grid, and let's go here to the customize. In customize, we have the units. The unit setup, I put it already 2 meters, and the system units 2 meters. Means I'm exporting everything in meters, but let's remember that RealFlow is dealing always with real world scale. So it's dealing with also meters. Every unit of these are 1 meter, is 1 meter. So I have 5, 5, 5, 5, which is 20 meters. And also I have 27 meters here, or 8, 27 meters. Yes, 27 meters. And just to make sure that we have the same units in 3D Max, I can go here, put top view, and I can use one of the tools to measure this, which is 27 meters. And if I go and measure this, it's almost 20 meters, which is exactly like I have in RealFlow. This is so good scenario because I don't need to rescale anything. And if I will go here, I need to keep everything as it is, one by one. No need to do anything here. So I have everything ready now, and I will hide the grid. Let's set up a few objects. So basically, I need to create Hybrido by going here. And also I need to create an emitter. So what we do is that the geometry which we want to emit the water from is usually built in 3D. That way we will make sure that we have exact area of fluid. But in this case, I didn't bring it from 3D. Let's build it here. All I need to do is to go to geometries and have one box. Let's scale it. Let's have some dimensions here. And let's move it in a way which it's just covering the area which I need the water to be in. Of course, I need it to cover all the area. So that would be suitable. Let's just make sure that we have everything contained. As example, I need this box to include all the particles, but I need to define also this box as a collision object. So RealFlow works like this. Because this would be a collision object, so I need everything inside it to be empty, which I can fill with particles with anything, but outside it I need everything to be solid. There's nothing here. That means all the parts of this box, which is the emitter in this world outside the container, will be empty. So I will make sure that it is bigger than the container, so I have all the particles inside. I can just reposition this object, but I think it's good now to start creating the Hybrido emitter and container. So to make everything more interesting, before we create the Hybrido setup, I went to 3D and I brought this plane, if you remember it. Just for a visual reference, because I don't want to display this one with all these walls whenever I need to see the land. And at the same time, I brought these two rocks. I imported them using the multi-body because I don't want them to be coming with the file, so I need to add them. So that would be the best way to import objects has no animation, and also I need to change their parameters together. So this is a group of objects, which is the two rocks. That's good. Now we need to do one thing before we proceed. I don't need this plan to be a part of the simulation. That's why I can just disconnect it from here. Right mouse button and remove from simulation or connection. And I can deactivate it also. As well, I will do that for these rocks. I don't need them here. And also I can deactivate them. And for the cube here, I need to create emitter. And automatically RealFlow will create a domain. If I will create domain, it will be created. Then I have to create the emitter, but now everything happened in one step. I don't need to have the domain above here because the position of the icon doesn't affect anything now. Later, if we will have a mesh, it will work like a clipping plan, as we will see later. But for now, we'll position it here. Before we start adding anything, let's do one thing. For the cube, already RealFlow established the relationship between the emitter and the cube. That's why we don't need to really have it in the simulation here. As you notice, if we will put everything aside here, we have the cube here. It was already connected here. I disconnected the cube from here, so it doesn't affect anything. And actually, I don't need to see it. That's it. We have all the setup. And we can add some forces to shape some interesting waves. Else we will have really steady and stable water, which has no interesting stormy waves, which is our purpose of this course, this tutorial, or this section of the tutorial. So I can go here and create ocean force. The ocean force is so interesting because it's a real-time, it can represent a real-time feedback of the wave. Let me show the cube for now. And the best position for it is above the surface of water, a little just on the surface of water. And the position affects really the shape of the wave. I should make it big as much as the water itself. That's good. And also I can visualize everything by just going here, and I can see the wave. It's a little random, but to see it in a clear way, we can go to ocean force, and here we can activate show field. As you can see, we have some force indicators or arrows, which we can see in all the surface by going to edit. And we can scale this up to include all the mesh. That's it. Now if I will run the animation, I will see how random it is. This is normal because this is what I expect from a general noise pattern or wave, which has no specific direction, but let's deactivate this one. But what we need is to have some waves coming from here in this direction, like rolling in this direction. To achieve that, we need to change some parameters. Let's do that. In the ocean force, I will leave the force as it is. The velocity is used for other purposes, but for now I will leave it as it is. The strength, we can increase this, but I will leave it now. Also, we can go to time factor first. As you can see, it's a little slow. It's not that fast. We can increase its speed to, let's say, 18. It may look very fast, but if I want to establish something stormy, I prefer to have this fast. And we can change it whenever we want. For the resolution, let's consider this as a map or an image, and based on the resolution, we have more details. But for now, let's leave it as it is because I really don't need much of details on this. This meant to produce big or large scale waves. For the small waves, we can use the displacement, which we will see later. And whenever we increase this, also it will consume the memory. For the depth doesn't really show much of effect here if it's larger, much larger than the main wavelength, which is the details, the actual details of the waves. But in general, if you study the waves, you will know that the depth affects the shape of the wave. And basically, whenever we have less depth, the waves will start disappearing. So I will just put any random number and we'll change it accordingly. For the dimension, 500 means that we have a scene which is 500 meters the surface of the water, which express how big the water is, and based on that how slow or fast it will move. I will just change it to 450 for now, because I want to see a big sense of movement, but at the same time maybe I will need to change it later. The actual size which I think logical to have is just this dimension, which is much smaller, but let's work like this and change accordingly. For the best way to do now before we change other parameters, let's go here and change this to 0, the wind direction. As you can see here, we have a wind direction which is going from here to here, but we want it to be the opposite. So what I can do is that I can flip it 180 or just 90. And to understand the direction here, if I will put 90 or minus 270, I will get the same result, which is specific direction. And if I want the wave to be from here to here, I can change this angle, or I can even rotate the node. I will just try to rotate the wave itself, and I can scale it to fit the scene. Now I can say that we have the wave we need. Let's change other parameters and make sure we have the best shape. Again, here I can see the wind alignment. The wind alignment, if I will change it, you will see exactly what I mean. If we will see it from here, we have some waves, which is not exactly. Look here, we have really one wave going one direction. And the idea about wind alignment is that if it's small, it will eliminate some of the waves which is perpendicular to the main wave speed. If it's bigger, it will eliminate all the waves which is not with the direction of the wind speed. And that's why we have all these waves. So let's jump to min wavelength, and it's just the level of details. I will leave it as it is for now. For the weight against wind, this number goes from 0 to 1, and basically all the waves which is against the wind speed can be eliminated totally by going to 1, or we can just have it there by going to 0, and between the two, 0.5, it gives us some kind of randomization, or just, various kind of waves, small addition. So it's good. Now this number, we can change it to any number just to give different distribution, unique different distribution. And for here, if you notice that I have just almost one wave moving, I can increase this number by going here and putting 2. Actually, that doesn't increase it. Let's go 1, and it changed V to 2. That's good. So we have now this wave. What else? Let's go up here and change this into another number, because I think this is a small number. Later we will see how it will affect the water, but let's put any number, and if it doesn't work, we will change it again. Now we have this display which we can fix by going again to the field and decrease this number, because it's just visual reference. It doesn't mean anything. Now, If you notice, the force here is almost the same as force here, but it should be actually strong here and weak here. So can we have some kind of attenuation? Sure we can. Attenuation axis, I can go here and choose, as example, I want it to be linearly attenuated on Z axis. But if you look here, this is X axis. Remember when we set up the scene, we set up everything based on Lightwave and Cinema 4D, which is basically flipping the axis. But also we can just take this in consideration. So what I can do is that I can go with this, and you can see that it works. And also I can attenuate the height by going to linear. Now I can increase it a little to see. That's what we will get. I think we are ready now to start simulating the wave, but before that, let's add some nodes which are important, such as the gravity node, which makes sure the particle is going to stay down, and it will be connected with everything automatically because it's connected to the hub. For the ocean force, I don't need it to really apply except on the domain, because as you will see later, we will simulate the domain, then we will add some additional particles like splash, like foam, but we will add them based on the domain movements. So I will disconnect it from here, and I will add it directly to the domain. We have the gravity now, and we can add also some drags. Force, which simulates the air resistance, and let's just change it to something and see what's gonna happen. Now for the ocean force, let's hide it. I don't need to see the cube also. And let's start simulating. I can hide the grid also, save everything, and we can start simulating things. And we can do that using simulate. I can press simulate here, and I can have everything in the viewport, but it will be slow. If I will go here, it's clipped in your screen, but it says command line. If I will press command line, I will have this icon, means if I will simulate, everything can happen in the background, and you will have the ability to see, discover, or just navigate in the scene and even change things. So we will go with that. Before we start the simulation, let's go to options and see here, hybrid. I don't need more than 1 by 1. This is good for everything here, and actually it's rarely needed to change this. We will do that in the whale project because we need more steps to calculate some collision between the splash and the whale. But for now, I will leave it 1 by 1 and I will proceed. Let's simulate, and I will come back after some frames. And this is the window. Let's see the first frame. I can just update by pressing this button, and I will have all the simulated frames here. As you can see here, we have some particles. We have almost 74 to 75,000 particles, which is really low amount of particles. But in the same time, it can show us a presentation of what we should expect. We always want to start with a few amount of particles. My advice is not to start with amount of particles which is so low. Don't go so high in the middle ground, because so low it doesn't present the final result, and very high it will be difficult to proceed and test all things before you get into decent result. So always I can update this to see more frames. As we can see here, the wave started. Again. I will just leave the simulation running, then I'll come back after it finishes. So we have some frames now. Can update the timeline and see we have really interesting movement. Although we have really few amount of particles. One of the most important thing is the location or the position of the ocean surface. I can push it a little down, change the location and see if we'll get better results, and I will come back. We have everything finished now, and as you can see, I can close this window. What I did is just I increased the resolution here for the cell size from 0.3 to 0.28, which increased number of particles from 70 something, 74 to 94, just to see more of the wave. And I just decreased the drag force to 0 for now. Later we'll increase it, but you can see that we have something interesting. Look at it from here, just as expected, but it's so regular. Of course, we can change some of the force parameters here, like adding some randomization by decreasing wind alignment, or by changing the seed, or also by changing the dimension so we have smaller kind of waves. But for now, this is what we have, and I think we can just move forward and start creating some white particles. Let's do that.